Hello and welcome to m200 Online Statistics at Cañada College. My name is Lapuz. In this video we will do a homework problem from section 5.3. It states that multiple choice questions each have 4 possible answers, A, B, C, or D, one of which is correct. Assume that you guess the answers to 3 such questions. They want us to use the multiplication rule to find the probability of getting a wrong answer, and a correct answer. Let's go to our Google Sheets and just type in some pieces of information such as the probability of getting a correct answer is 1 out of 4 choices, and then the probability of getting a wrong answer is going to be the complement of that, or 3 out of 4 choices. Notice my 1/4 didn't really come out as a fraction or a decimal. That's because I didn't have it compute 1/4, and if I wanted to see the decimal, I would say 1 equals 1 divided by 4, or equals 3 divided by 4 for the probability of getting a wrong answer. Now they want us to find the probability of getting a wrong answer the first time, getting a wrong answer the second time, and getting the correct answer for the third time. For this one, we are interested in getting the wrong answer, and that probability is 3/4. And then we're going to multiply it by the probability of getting a wrong answer again, and then we're going to multiply it by getting the probability of getting the correct answer. So this is 3/4 times 3/4 times 1/4. I think that just multiplies the numerator altogether, which is a 9, and then multiply the denominators together. That's 4 times 4 is 16, times another 4, I believe, is 64. So let's check our answer. Typing in the exact value, 9/64. Okay, that looks good. Beginning with WWC, a wrong, and a correct answer, make a complete list of the different possible arrangements for 1 correct answer and 2 wrong answers. If we change the order of this, for example, we want to get a wrong answer, a correct answer, and a wrong answer, we would essentially be multiplying the same things. A wrong answer is 3 out of 4, a correct answer is 1 out of 4, and then another wrong answer is 3 out of 4. So if we switch the order of these things, we're multiplying the same numbers, and since it doesn't matter the order of our multiplication, we're still going to get the same answer. So it looks like all of these will be 9/64. And then in this last problem, they want us to find the probability of getting exactly 1 correct answer when 3 guesses are made. Well, we have this 9/64 happening for the first one, the first possibility, and the second possibility, and there's only really one other possibility, which we already saw in the problem. And all these have a probability of 9/64. So if we were to add that, we would add 9 plus 9 plus 9/64, the same common denominator. Let's just make sure that we're adding it correctly. That looks like it'll be 27/64. So all this total will be 27 over 64. Let's try putting that as our answer. Alright, we got the answer correct, but I want to show you another point of view for this problem. This is the probability of getting 1 correct out of 3. That turns out to be a problem from a binomial distribution. Let's think about it. A binomial distribution has a fixed number of trials, and the number of trials here is 3. N equals 3. You either get a wrong or right answer. So answers are either one of 2 choices, and it's either right, correct, or incorrect or wrong. We have a constant probability, and the probability in this case for getting a correct answer is 1/4. And the trials are independent is our 4th criteria, and we can just say that they are independent because you're randomly guessing this 3-question quiz, and so you're not saying that one is dependent on the other. So given that this is a binomial distribution, we can actually construct a binomial distribution table. And the binomial distribution table has x in a p of x column, and then the values that we have for x are going to be 0, 1, 2, all the way up to whatever n is equal to. In this case, it's a short list. We only have 3. In constructing this binomial distribution table, we need the probabilities, and so there's a complicated formula that we have in the textbook, but we can take advantage of the spreadsheet formula. And for us to find formulas, if you're not ever sure of formulas, you can search the function menu, and in this case it's a statistical function, and it's a binomial distribution function. So binomial distribution probability should work. This binomial distribution probability is another version of it, so let's just pick one of them. It's asking us for the number of successes, so we're going to make a table out of this, and the number of successes that we're going to want is going to be your random variable x. The number of trials is a fixed number of trials, it's 3, so we'll type 3 in. The probability for success, we know that to be 1/4. That's the probability of getting a correct answer. And then they're asking us, do you want this as a cumulative distribution? No, because we're going to make a table out of this. There will be times where you would want a cumulative distribution, but in this case we won't. So I'll type false and hit enter. Now the nice thing about spreadsheets is that if you have a formula all set up, this is the probability for 0. We're going to want the probability for 1, for 2, for 3. You can just take this cell, click and drag down, and then you're going to have your distributions filled out. What we were looking for was the probability of getting exactly 1 correct, and that we found to be 27 over 64. Let's make this into a decimal so that we can compare it 27 out of 64. And before I press enter, I want you to notice that this is the probability of getting exactly 1 correct. And if we compare that, we see that it's exactly the same. Okay, so I just wanted to tie in this problem with a binomial distribution, and it's all based on the binomial distribution function and its criteria. As long as that matches, then we can use this. Alright, I hope that helps.